In this episode, we begin looking at vulnerability management as an ongoing security process, not a one-time scan or a single report. A vulnerability is a weakness that could be used to harm confidentiality, integrity, or availability. That weakness might exist in an operating system, application, cloud configuration, network service, source code, device firmware, or business process. Vulnerability management is the organized way an organization finds those weaknesses, understands what they mean, decides what matters most, fixes or reduces the risk, and verifies that the fix worked. The important part is the cycle. New systems are added, software changes, cloud services are created, code is updated, attackers learn new techniques, and vendors announce new weaknesses. A clean scan today does not prove the environment will be clean next month. Vulnerability management gives security teams a repeatable way to keep looking, keep improving, and keep reducing exposure over time. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.Me in the Bare Metal Study Guide series. A vulnerability scan is one of the most visible parts of this process. A scanner checks systems, applications, network ranges, or services for known weaknesses, missing patches, insecure configurations, outdated software, exposed ports, default settings, or other signs of risk. The scanner may compare what it finds against known vulnerability information and configuration checks. It may report that a server is missing an update, that a service is using an older version, that a certificate is expired, or that a system exposes a risky management interface. Scanning is useful because manual checking would be too slow in most environments. Even a small organization can have many laptops, servers, applications, cloud resources, and network devices. A scan gives the security team a broad view of possible weaknesses. It does not solve the problems by itself, but it helps the organization see where attention is needed. Scanning can happen from different perspectives, and that perspective matters. An external scan looks at what is visible from outside the organization, often from the internet. This can reveal exposed services, public-facing applications, remote access portals, cloud resources, or misconfigured systems that an outside attacker might see. An internal scan looks from inside the network or inside a trusted environment. This can reveal weaknesses that may not be visible from the internet, but could matter if an attacker compromises a workstation or gains internal access. Authenticated scanning uses valid credentials, so the scanner can inspect a system more deeply. It may find missing patches, installed software, local settings, and configuration details that an unauthenticated scan cannot see. Unauthenticated scanning sees less, but it may better represent what an outsider can learn without logging in. Each scan type answers a different question, so mature programs often use more than one perspective. A scan result should not be treated as a perfect truth. Scanners are helpful, but they can be wrong, incomplete, or misunderstood. A false positive happens when the scanner reports a problem that is not actually present or not actually exploitable in that environment. A false negative happens when the scanner misses a real problem. Scans may also lack business context. A scanner can tell you that a vulnerability exists, but it may not know whether the affected system processes customer payments, runs a test workload, supports emergency communications, or sits unused in a lab. That context changes priority. Scan results need review, triage, ownership, and follow-up. The report is not the finish line. It is a starting point for decisions. A good vulnerability management process turns scan data into action by assigning findings, setting due dates, tracking status, and confirming whether remediation actually happened. Internet Protocol Address Management, IPAM, supports vulnerability management by helping the organization understand which Internet Protocol, IP, addresses exist, what they are assigned to, and how they relate to networks and systems. That may sound like a narrow networking task, but it matters a lot for security visibility. If a scanner is supposed to check all systems in a range, the organization needs to know which ranges exist and what they contain. If an unknown device appears on an address, security teams need a way to identify it. If a cloud network, office subnet, data center segment, or lab environment is missing from the scan scope, vulnerabilities there may go unnoticed. IPAM helps maintain a map of address usage so security teams do not scan only the systems they already remember. It reduces blind spots by connecting network addressing with asset awareness. IPAM also helps with ownership and investigation. When a vulnerability scan finds a serious weakness on a specific address, the team needs to know what system that address belongs to, who owns it, what it does, and whether it is still active. Without good address management, responders may spend valuable time chasing stale records, guessing from host names, or asking multiple teams whether they recognize the system. Address reuse can make this even more confusing. An address that belonged to one server last month may belong to a different system today. Dynamic addressing, temporary cloud resources, remote work networks, and segmented environments can all make the picture harder to maintain. IPAM does not fix vulnerabilities directly, but it helps make vulnerability work traceable. It connects findings to real assets and real owners, which is necessary before anyone can patch, isolate, retire, or accept risk. Cloud Security Posture Management, CSPM, focuses on finding risky configurations and compliance gaps in cloud environments. Cloud security creates a different kind of visibility challenge because resources can be created quickly, changed through automation, exposed through configuration choices, and spread across accounts, subscriptions, regions, or projects. A traditional network scan may not see the full picture. CSPM tools look at cloud settings and compare them against security policies, best practices, or compliance requirements. They may identify storage that is publicly accessible, overly permissive identity roles, missing encryption, logging that is disabled, exposed management interfaces, weak network rules, or resources deployed outside approved regions. This is important because many cloud incidents come from misconfiguration rather than a classic missing patch. CSPM helps organizations continuously check whether their cloud environment is configured safely. CSPM is especially useful because cloud environments change faster than many traditional environments. A developer may create a storage bucket for testing. A project team may deploy a new database. An administrator may temporarily open a network rule and forget to close it. A template may accidentally create resources with weak defaults. A service account may receive more permissions than it needs. Each change can create exposure. CSPM gives the organization a way to detect drift, which means the environment has moved away from the approved or expected state. It can also help compare cloud resources against policy. For example, the organization may require encryption, logging, limited public access, and approved regions for certain data. If a new resource violates those expectations, the tool can alert or sometimes help trigger remediation. The goal is continuous posture awareness, not one annual cloud review. Source code review is another part of vulnerability management because some vulnerabilities are created inside the application before the application is ever deployed. A source code review examines the code and related logic to identify weaknesses such as unsafe input handling, broken access checks, hard-coded secrets, weak error handling, insecure cryptography, risky dependencies, or business logic flaws. This can be done manually by people, with automated tools, or through a combination of both. Manual review can understand intent and context better, especially when the weakness depends on how the application is supposed to behave. Automated review can cover large amounts of code quickly and find known risky patterns. The value is that problems can be found earlier, when they may be easier and cheaper to fix. Waiting until an application is live can make remediation slower, more expensive, and more disruptive. Source code review connects vulnerability management to the software development process. If a team writes new code every week, the vulnerability picture changes every week too. A secure version of an application can become vulnerable after a feature is added, a library is updated, an access check is changed, or a new input field is introduced. Reviewing code helps catch those weaknesses before they become production risk. Static application security testing, SAST, examines code without running it, while human review can look at whether the design and logic make sense. The goal is not to shame developers or slow everything down. The goal is to give useful feedback early enough that secure choices become part of normal development. Vulnerability management is stronger when it includes applications being built, not only systems already running. Vulnerability management also needs asset inventory because you cannot scan or review what you do not know exists. A vulnerability scanner may be configured well, but if a network segment is missing from scope, the systems there may remain unchecked. A CSPM tool may cover one cloud account while another account is unmanaged. A source code review process may cover the main application but not internal tools, scripts, or small services that also handle sensitive data. Inventory helps define scope. It tells the organization which systems, applications, addresses, repositories, cloud resources, and data environments should be included. This is where asset management and vulnerability management connect closely. Asset management answers what exists and why it matters. Vulnerability management asks what weaknesses exist in those assets and what should be done about them. Without inventory, vulnerability work becomes partial and unreliable. Remediation is the action taken to fix or reduce a vulnerability. That may mean applying a patch, changing a configuration, removing unsupported software, closing an exposed port, rotating a secret, updating a library, correcting source code, reducing permissions, enabling logging, or decommissioning an asset that is no longer needed. Sometimes remediation is straightforward. A missing update is installed, and the finding goes away. Other times it requires planning because the fix could affect business operations, require vendor support, or need testing. When a direct fix cannot happen immediately, the organization may use a compensating control. That might include segmentation, access restriction, monitoring, disabling a risky feature, or placing a web application firewall in front of a vulnerable application. A compensating control does not erase the underlying weakness, but it can reduce risk while a permanent fix is prepared. Verification is what confirms that the remediation worked. If a team says it patched a server, the vulnerability management process should verify that the server no longer appears vulnerable. That may require rescanning, checking configuration, reviewing version information, confirming a code change, or validating that a risky cloud setting has been corrected. Verification matters because fixes can fail. A patch may not install correctly. A system may roll back after reboot. A configuration change may be applied to one server but missed on another. A cloud policy may be changed in the console but overwritten later by automation. A code fix may close one path while leaving another similar flaw open. Without verification, the organization may close tickets based on intention rather than evidence. Good vulnerability management does not stop at assigned or fixed. It asks whether the risk was actually reduced. Reporting keeps the process visible and accountable. Security teams, system owners, application teams, cloud teams, and leaders need different levels of information. A technician may need exact affected hosts and remediation details. A system owner may need to know which assets they are responsible for and when fixes are due. A leader may need trends, overdue critical findings, high-risk business areas, and whether risk is improving or getting worse. Reporting should not be just a pile of scan results. It should help people make decisions. Useful reporting can show recurring weaknesses, systems that miss patches repeatedly, cloud areas with frequent misconfigurations, code repositories with repeated secret exposure, and teams that need support. Good reports also make progress visible. Vulnerability management can feel endless because new findings keep appearing. Reporting helps show whether the organization is reducing exposure over time. For Security Plus questions, focus on the part of the process being described. If the scenario describes looking for known weaknesses across systems or networks, think vulnerability scanning. If it describes mapping addresses, identifying what uses a network address, or making sure scan scope includes the right ranges, think IPAM. If it describes checking cloud resources for misconfigurations, risky permissions, public exposure, missing encryption, or policy drift, think CSPM. If it describes examining application code for security weaknesses before deployment, think source code review. If it describes assigning fixes, applying patches, changing settings, or reducing exposure, think remediation. If it describes rescanning or confirming that a fix worked, think verification. The exam may use practical scenarios rather than definitions, so read for the action being taken and the environment where the weakness exists. The larger lesson is that vulnerability management is a continuous cycle of finding, understanding, fixing, and verifying weaknesses. Scanning helps reveal known issues across systems and services. IPAM helps the organization know which address spaces and assets should be included. CSPM extends visibility into cloud configuration and posture, where mistakes can appear quickly. Source code review catches weaknesses in applications before they become live production problems. Inventory provides scope, remediation reduces risk, verification proves the work was effective, and reporting keeps the process accountable. This is why vulnerability management should never be treated as a one-time tool run. Environments change, attackers adapt, software ages, and cloud resources shift. A strong program keeps cycling through discovery, prioritization, action, and proof. When you understand that rhythm, vulnerability management becomes less about reports and more about steady risk reduction.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.